This technology is extremely unique. People have been going after this holy grail of warm gas cleanup for decades. No one has succeeded except RTI, and we found no one else that has a competitive technology that can remove the sulfur at these kind of temperatures, particularly as quickly as we do. The Department of Energy got involved because part of their drive is to try to lower the cost for using coal and other resources to produce power, fuels, and chemicals. And one of the things that always has held back the gasification process is its high capital cost. So they were looking for things that could start reducing the cost, and also wanted to improve efficiency. When you improve efficiency, it helps you on a number of fronts, environmentally as well as lowering the cost.
This technology allowed the Department of Energy to see that coal could be used cleanly. The idea was that any CO2 we capture from this technology could be safely sequestered or utilized. Then essentially you will not emit any CO2 out in the atmosphere.
We have actually gone with a transport system where we circulate the material back and forth between an absorber reactor. We remove the contaminants, and a regenerator where we introduce air, burn off the contaminants, and can send it off for separate treatment. We constantly receive comments how they are amazed that we have actually managed to have the sorbent perform as well as it has, as long as it had, under the rather adverse conditions we have subjected it to. And right now, when you look at the syngas we're actually treating at the demonstration plant, we're removing the 99.9 plus H2S and COS. Most technologies will remove one or the other. Our technology simultaneously removes both.
It has a very unique sorbent. That's one of the keys to its success, is a sorbent that not only has high sulfur capacity, but also very good attrition resistance, meaning it can go around the transport system without breaking apart, and also be almost infinitely regenerable, go through multi cycles. In fact, we've had sorbent last 2 to 3 years without a significant loss in sulfur removal performance.
And we have 3 units. We have our desulfurization technology, which removes the sulfur. We then have a water gas shift reaction block, which essentially takes the CO, converts it to CO2, so we can get essentially a very high purity hydrogen product out. Then we have an activated amine process that essentially extracts the CO2 and any remaining H2S or sulfur compounds. So the fuel we get out is essentially a very clean and high purity hydrogen.
Altogether, we've got about 4,000 operating hours with syngas operations and through the warm gas cleanup block, and about 1,000 hours of total integrated operation with every system, not only the warm gas cleanup, but the water gas shift and the amine carbon capture unit that captured up to 90% of the carbon from the system. We're able to show and demonstrate that the warm gas desulfurization sorbent performed at this near commercial scale, just like it did at the pilot scale, just like it did at the bench scale and the lab scale. The very interesting thing is when we went from the warm desulfurization process and took that clean syngas, fed it to the carbon capture block, which was an activated amine system, it gave an additional almost 100x removal of residual sulfur. So we went down to sub-part per million levels of total sulfur in the clean syngas, which is a level never before seen with this type of system. Almost always you end up trading off one of those benefits for the other. You may get lower capital costs, but it comes at the expense of higher operating costs. You may get a cleaner material, cleaner output of product, but at the expense of more capital investment, which is what usually happens, particularly with environmental treatment technologies. So this one's kind of unique in that you win, 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 and on all fronts, the capital, the operating cost, efficiency, and the environmental performance.
So anybody who's looking at a coal gasification plant, whether it's for the power generation, that means IGCC, or making methanol or ammonia or hydrogen, should definitely take a look at this technology, because what it allows you to do is it allows you to remove sulfur up front from the syngas, and then whatever you need to do with the syngas, you can adjust the CO2 removal accordingly. So that way you're not stuck removing sulfur and CO2 and working with the limitation of the existing technology. This will significantly reduce capital cost and operating cost and improve the efficiency and simplify the process tremendously.